On the first example from the released EOC questions, we see that it's asking, the figure below was formed by joining two segments of equal length at common endpoint y. If x, y, and z are non-collinear, which the following statements regarding x, z must always be true? Well, realize that we're talking about x, z, so we're actually talking about this segment right here. If we look at that blue segment, it doesn't equal xy. There would be no way that it could. So A is not our answer choice. xz equals 2 times xy. If that were the case, since both xy and yz equal the same thing, we would actually wind up with one flat line. So B also can't be our answer choice. xz is greater than 2 times xy. Again, if it's greater than, then we do wind up with a situation that it wouldn't actually close to have two that are equal. If we were to draw that, we would say that we have xy, yz, and then xz would be twice as long. xz is less than 2 times xy. Now this would be our option. This is our option because if you remember back to learning about triangles, we learned that A plus B must be greater than C. So the sum of two sides must always be greater than the third. D is our correct answer. On the second EOC example, it asks that if two sides in a non-included angle of one triangle are congruent to two sides in a non-included angle of another triangle, then the two triangles are congruent. Which diagram can be used as a counterexample to the student's conclusion? Now remember, what counterexample is saying is that one example that makes this whole statement false. Well, if we look in part A, we do have an angle side-side, which is also a hypotenuse leg. A does prove congruency, therefore it's not an option. On B, we again wind up with an isosceles triangle where we do have the situation of a right triangle here. The reason we know it's a right triangle is if we have two angles that are congruent, then we know that we have a perpendicular bisector. B also proves congruency. On C, we have vertical angles, which are congruent. We wouldn't only need to do this by angle side-side, we could also do it by angle side. So therefore, we do have two congruent triangles. D obviously looks the most incorrect as a counterexample. If we look at this angle side-side, we don't have anything where we have a perpendicular bisector, and there's no other indication that these bottom two sides are congruent. So therefore, D is our option. On the third example from the EOC release questions, it's asking which set of statements represents a valid deductive argument. Well, remember, a deductive argument is one that goes from a general idea to a specific case. The first example, A, all quadrilaterals have four angles, all parallelograms have four angles, all quadrilaterals are parallelograms, is not a logical argument, simply knowing your facts about quadrilaterals. C would also be one that we could discount because not all rectangles are squares. All squares are rectangles, but not the other way around. Let's look at B. All parallelograms have diagonals that bisect each other. All parallelograms have opposite sides that are parallel. All polygons whose diagonals bisect each other have opposite sides that are parallel. We could actually disprove this by a counterexample, but there's nothing in here that talks about polygons. So therefore, we can't immediately jump from parallelograms to polygons. B cannot be our answer. So we are left with D, but let's look at why it's the correct answer. All parallelograms have four sides. All polygons with four sides are quadrilaterals. All parallelograms are quadrilaterals. We could actually take out through the law of syllogism, all parallelograms have four sides. That four sides is repeated in the next line, and then join together our beginning and our end.